Good morning, student. Let's start today's class. Today we are going to study about common emitter connection of transistor. Okay. In previous class we have studied about common base connection of transistor. Today we studied about common emitter connection. Okay. In this circuit arrange. Okay. You know you know common emitter means emitter is common here. Okay, so the let's say this is the transistor. 1 minute. This is our transistor. Okay, this is, let's say, collector. This is base. This is emitter. Common emitter means emitter is common for input and output. Okay, so here the input is base and emitter. This is input, and collector and emitter is output. Okay, collector emitter is output, base emitter is input. So emitter is common for input and output. Okay, here you see, here also you see, this is the common emitter. Okay, this is emitter, this is the input, base and emitter, this is input. Okay, and collector and emitter is output. Okay, so this is common emitter. Okay, here emitter is common. Okay, now let us see the basic current amplification factor. We have already studied about the current amplification of common base, which is alpha. Okay, in previous class, and here the current amplification factor here is beta. Okay, remember that alpha is current amplification for common base circuit, but beta is the current amplification of uh, common emitter connection. Okay, then the ratio of range of collector current to the range of base current is known as base current amplification. Okay, this is the beta is delta IC by delta IB. Okay, remember this. Okay, now let us see the relationship between beta and alpha. Okay, beta is known, beta is that IC by IB, delta IC by IB. Alpha, you know, in previous class we have discussed that, we have studied that alpha is delta IC by delta IB. Okay, so and we know that IE equal to IB plus IC, previously know that. So delta IE also delta IB plus IC. Okay, so IB equal to, from here IB equal to IE minus IC. Okay, so in the place of, in beta, in the place of IB we place this. Okay, so here is beta equal to delta IC by delta IE minus delta IC. Okay, now in LHS and RHS, okay, sorry, in the upper side and the lower side we both divide IE. Okay, so IC by IE by IE minus IC by IE. Okay, so IC by IE, you see, this is alpha. Okay, so here alpha, IE by IE equal to 1, so here IC by IE equal to alpha. So we prove that beta equal to alpha by 1 minus alpha. Okay, this is, remember this relationship. This is called base current amplification factor, and this is called what is emitter current amplification factor. Okay, now in this, it is clear that as alpha approaches unit, beta approaches infinite. Okay, in previous classes we have studied that alpha is maximum value of alpha is unit. Okay, or alpha value may vary from 0 to unit. In commercially the alpha unit is 0.999. Okay, so here if alpha is unit, let's say unit, 1 unit, then the beta is infinity. Okay, you see, you place 1 by 1 minus 1, which is 0. So 1 by 0 is infinity. Okay, so whenever alpha is unit, beta is infinity. Okay, in other words, the current gain in the common emitter connection is very high. Okay, since the beta is infinity, the current gain emitter or the current gain. Okay, current gain means means what? The gain of current from input to output, or whenever we since current gain means, you see, the amount of current we used in input signal get amplified here in the output signal, and this amplification, how much amplification are there, that is called current amplification factor. Okay, since we, let's say we here 2 ampere we used in input, we get, let's say, 5 ampere. So the current gain is 5 ampere by 2 ampere. Okay, how much increase or how much amplification is there, that is called current amplification. If that amplification is infinite, or that means the current amplification is very high, so we so that it is due to this region. Since the current amplification is very high, the common emitter connection, it is due to this region that the circuit arrangement is used in about 90 to 95% of all transistor applications. Remember that the current amplification of common base, in previous classes we have solved that the current amplification factor in common base, okay, connection, which is alpha, equal to maximum 1. 1 means, you see, the if we uh, applied input 2 ampere, we maximum output get 2 ampere. Okay, this is input, this is output. Okay, this is common base. Okay, so if we apply 2 ampere, we maximum get 2 ampere. So this, there is no use of this amplification, or this use of this transistor, because we applied how that much, we get output in that much, so we don't want any circuit between them. Okay, but in common emitter case, what happened, we if we applied 2 ampere, then we get infinite or very high, let's say 2000 ampere or 200 ampere. This is very high. This is only possible in common emitter connection. So this is for advantages of our use. Okay, that means we use this circuit in many places. We can use this because we want, whenever we want very high current from low current, we use this network. Okay, so this connection is used in 90 to 95% of transistor application. Okay, then now let us calculate the expression of collector current. You can understood this collector current, that IE equal to IB plus IC. Previously know that IC equal to alpha IE. Alpha IE means we know alpha equal to IC by IE. Okay, IC by IE. So here alpha IC, where here IC equal to alpha IE. Okay, this is also we previously know that from common base. This is also we know that IC equal to IE plus ICBO. ICBO is a leakage current. Previous class I told you that. Then by using this expression is coming. Okay, that means this IC equal to beta IB plus ICO. Okay, remember this expression. Okay, now let us see the concept of ICO. ICO means common emitter. Okay, in this common emitter configuration, a small current collector current flows even when the base current is 0. That means in previously or previous common base we see the leakage current which is ICPO. Okay, common base current in the emitter whenever the emitter is opened. Okay, this is the common base configuration. But in common emitter configuration, ICEO, that means the common emitter current in the when the base is open. Okay, similar thing. Okay, this ICO is similar to the ICVO. Okay, now let's see the characteristic. Okay, the characteristic of common emitter connection. This circuit used to draw the characteristic of common emitter configuration. Okay, and the common emitter the characteristic is two types. Okay, one is input characteristic, one is output characteristic. The first of all, what is input characteristic? You see, this is the input characteristic. Okay, the x-axis is VBE, that means base emitter voltage. Okay, and the output in the y-axis is IB current. Okay, the curve is, and the VCE when the VCE constant. Okay, you see, this is the characteristic of input or input characteristic of common emitter. Okay, remember this. Okay, that means the V the V sorry, the current is the characteristic resemble that for a forward bias diode curve. Okay, this is resemble as a forward bias diode. Okay, this is expressed in the base emitter connection circuit section of a transmission is a diode and it is forward bias. Okay, and as a compared of a common base arrangement, IB increases less rapidly with VBE. Okay, this IB increases rapidly in common base, but here the IB is increase less rapidly. Okay, this is the input characteristic. And input resistance. Okay, you know, remember this input resistance Ri is del VBE by del IB. Okay, now the output resistance. Okay, the output, 1 minute, the output resistance is this. Okay, is like the common base output characteristic. Okay, sorry, output characteristic of common emitter is like output characteristic of common base. Okay, then output resistance R0 is del VCE by del IC. Okay, at constant IB. Okay, thank you. And this is the knee current. Knee current in transistor in diode case, I told you what is knee current. Knee current means the minimum current from where the barrier of the or the diode is breakdown. Okay, that is called knee current. Okay, that's the common emitter configuration connection of transistor. Okay, thank you.